Welcome everyone. Hey, this is Bryce. I'm just following up on a video we have done on MemoryStore, the speedy in-memory key value store. So when developing my own projects, I needed something like Redis or Memcache to store values temporarily in memory for easy access in my APIs. And it's just setting up Redis or Memcache was complicated sometimes, and I just needed something quick and simple. So I developed my own in-memory data store. And so I've already gone over the high-level details. Please go ahead and check out that video if you want to know a little bit more about this. But in this video, we're going to get into the details of how I implemented this. So again, go ahead and watch the first video if you haven't, but also please make sure to like this video and subscribe if you enjoy the content and to follow with what I do. Cool, so let's get into it. So in this MemoryStore repo, it's called MemoryStore, and then I have another folder called MemoryStore where the actual file lives, where it implements our in-memory data store. So the package is MemoryStore. It's the same as the folder name. We import some things here like context, sync, and time. So context is going to allow us to get the background information so that we can clean up our data store. And then the sync is going to allow us to apply mutex operations so that we can read and write from the map safely without overwriting or messing up any data there. But that's not thread safe. So anyways, so we also have the time, so we can measure time, obviously, so we know when to remove things from our data store. Okay, so we have some type. It's called an item. It's a structure, and the value is a slice of bytes, and we give it some expiration time when it expires. So our memory store is going to be the structure which holds our mutex, read-write mutex, the store, which is actually just a map from a string to the slice of bytes, an item, which is a slice of bytes and an expiry time. We give it a context, and we give it a cancel function. And then we have a constructor here, so we have a function that creates a new memory store. We give it a context with cancel, with the context.background. We define it as MS. It's the address of the memory store, and the memory store consists of a store, which is a map that goes from strings to items, context, and a cancel function. And then what we do is we start this cleanup worker, which is going to run in the background. It's going to run a Go routine. Okay, so let's talk about that start cleanup worker real quick. So it acts. It's the receiver, the memory store. Its start cleanup worker is a Go function. So this function is just a wrapper around a Go function. We give it a ticker and we say, hey, every 1 minute, clean up expired items. Otherwise, keep going. If it's done, stop and then return. Cool. And there's the stop method, which is the cancel function that we passed in at the construction time. Okay, so this cleanup expired items is going to, every 1 minute, we're going to lock our map, and then what we're going to do is defer the unlock. So once we exit out of this function, then we'll unlock. And then we're going to iterate through the map, the data store, and we're going to say if the time.now after item.expired at, then we're going to delete the key from the data store. Otherwise, we just continue on. Okay, so that's how we clean up items from there. We're going to just iterate through all the keys and remove things in which the expiry time is happened before right now. So it should have expired. Okay, so now this memory store structure needs a couple of methods. We obviously have this construction, and then we have this background worker. But we also need to set and get. So set in this context is going to be, we have a map. We're going to put a slice of bytes to the string. So if we have Alice and Bob, and Alice is a string, and the value of Alice is some slice of bytes, which is probably like the JSON object that represents her structure, if she was like a person struct or something like this. And so what we want to do is we want to put data in our memory store. So we say, hey, we're going to place it at this key, which is a string. We're going to give it a value, which is these bytes. And then we're going to say, hey, like in 5 minutes, delete this if it hasn't been used. So we're going to lock our memory store, and we're going to defer unlock. We're going to place at the key an item which has the value of slice of bytes, and then when we give it the expiration date. And then we're going to return nil because everything was great. Okay, and then we have a get method. So the get method is going to do effectively the same thing. It's going to lock our map so that it can't be updated while we're trying to access information inside of it. And we're going to see if the key exists in our map. And then if it doesn't exist, or the time right now is after the item expiry, then we're going to say, hey, like this item doesn't exist, and we're going to return false because we didn't actually get the item. Otherwise, we know that the value does exist, and then we're going to turn that value in true. Cool. So what we can do now is, with these two methods, the get, set, and get method, is we can put stuff in the map, and then we can retrieve information from that map in a thread-safe way, because we lock the map while we access members inside the map or place data inside the map. Now we also need a delete method, which is literally what it means. So we want to, again, lock the map, make sure it can't get updated while we're trying to access information inside of it. Defer unlock, so that when we exit this function, we will unlock the map so other functions can access it. And we're going to delete the key from the data store. This is a very, very simple implementation. I'm sure this can be taken many different ways from here, but this has worked very well for me for scaling up my own APIs. And you can implement this very quickly. So I found this to be extremely useful for my own projects, and hopefully you can find it useful for your own. And if you don't use this particular package, then hopefully you'll have learned something about implementing your own Go modules, and learning how to write perhaps unit tests for those. We can cover unit tests in the next video. So if you like this content, please like, please subscribe, and then yeah, see you in the next one. Hope you have a good day. Bye.